Dear student, today is my second lecture. Now I am going to facilitate you by giving you some fundamental topics regarding the ordinary differential equation. In first lecture we have discussed the existence and uniqueness of the differential equation, ordinary differential equation. In that time, I have told you that if we can measure or examine the existence and uniqueness of a first order ordinary differential equation, then it can be generalized to the next higher order. How does it occur? Because any nth order differential equation can be reduced to a first order set of ordinary differential equation. That means if nth order differential equation exists in some domain, then n first order differential equation can be derived from that differential equation. That's why if once we can realize the existence and uniqueness of a first order ordinary differential equation, then we can examine the existence and uniqueness of the nth order differential equation. That's why first order differential equation we have chosen. In that lecture, we have discussed why the differential equation is so important in our mathematics students. In mathematics background, differential equation is so very vital, plays very vital role, because there are so many system or anything can be expressed by mathematics, and differential equation is the most fundamental one. First of all, why do you read differential equation? This is new topics. Why do you read? What is the benefit we can get by reading this? So what is the that's before I want to tell you that my lecture is bifurcated in 4 portions. First one is the differential equation, how many differential equations are there, and the definitions, and some examples of each of these types of differential equation, and we discuss some features of the differential equation, and we conclude the ultimate way. So this is the most fundamental one. Why do we read differential equation? Because differential equation is a concise form of expressing some properties of family or group of functions. In our real world, many laws are derived by the help of the differential equation. Many laws. Just like at that, the Newton's second law, P equals to mf. That means if P means force, F means the acceleration. And why do we write like that? It can be write like that: m d2x dt square is proportional to force. That is differential equation. And here we have given 2 different examples of 2 differential equations which can be derived from our real situational world. That is, first one is d2x dt square equals to minus kx. It is the simple pendulum motion. How does simple pendulum motion behaves can be described by this differential equation. And Next one is dn dt equals to an minus bnm, and dm dt equals to cnm minus dm. This together represents a nature of our population dynamics. N represents for number of species and M represents number of predator, that means predator-prey model. What does it mean? If we explain this thing, it is more easier to you. First of all, N means number of species of prey. Prey means what is eatable. That means if we give some example in our nature, that means if deer is a prey and tiger is the predator, the number of prey, that means N, and that is deer, number of deer equals to N, and the number of tiger, that is M. So in our forest, this type of dynamics occurs. That means dn dt, rate of change of the deer population, is equals to an, that means it is abruptly increasing, a is positive, and bnm, that means what does it mean? nm, that means interaction between the deer and the tiger. When tiger eats deer, then it is denoted by nm. Then what would be the tiger population? Then dm dt, rate of change of population. If tiger eat deer, then its population size will become larger, that is cnm, and minus dm, that means the mortality rate of, that is the death of the predator. So second one gives the most natural example of our environment, which can be represented by the differential equation. So now that's why differential equation is so much important in our study. Now we going to the further. What is that? Now we first have to know what is differential equation, the definition of the differential equation. So what is differential equation? Differential equation, an equation involving derivatives or differentials of one or more than one dependent variables with respect to one or more independent variables is called differential equation. This is so simple. If derivatives or differential involved in an equation which may be some function of one or two variables, or it is a function of more than one or two independent variables, this is called the differential equation. Now we give some examples of the so differential equation can be broadly divided into two parts. First one is ordinary differential equation and second one is the partial differential equation. Ordinary differential equation means dy dx. If this type of derivatives occurs in the differential equation, this is called the ordinary differential equation. And partial derivative differential equation, what does it mean? If partial differentiation involved in the differential equation, then this is called partial differential. If we go to the next slide, then we give some examples. So see some examples of ordinary and partial differential equation, so that we can distinguish ordinary and partial differential equation both. What is that? What is the definition of ordinary differential equation? A differential equation involving ordinary derivatives of one or more dependent variables with respect to a single independent variable. It is the most vital, most important thing is that ordinary differential equation only depends only on a single independent variable, that is ordinary differential equation. And the partial differential equation, if the independent variables is more than one, then partial differentiation is come to play. That's why if a differential equation involving partial derivatives of one or more dependent variable with respect to one or more than one independent variables is called partial differential equation. So now we give some examples of the partial differential equation so that we can distinguish which is ordinary differential equation and which is partial differential equation. In equation number 3, what do we see that? We see that d2y dx square plus xy into dy dx whole square equals to 0. Here we can see that only ordinary differentiation involved here. Only ordinary differentiation involved here. First one is, first one is, what is that? That is only ordinary differentiation involved here. So it is ordinary differential equation. And in equation 4, it obviously contain the ordinary differential equation, that is d2y dx square. Here only one independent variable is x, and the derivatives involved here d2y dx2 and dy dx. So these are all ordinary derivatives. That's why equation 4 is ordinary differential equation. And what is that second? What about the equation number 5? This equation number 5 is that d2y dx square equals to 1 by c square del 2y del 2. Sorry, there is a spelling printing mistake. This should be del 2y del x square equals to 1 by c square del 2y del t square. Here we see that there is two independent variable, that is x and t. That's why and the derivatives involved here are partial derivatives. That's why this is partial differential equation, and it is very important partial differential equation. You can note it that it is the wave function. It produces wave function, that is this equation is known as wave equation. And what about the equation number 6? Here we see that x, y, z, these three are independent variables, that and u is only the dependent variables, and del 2u del x square, del 2y del x del square, del 2u del z square occur here, and this is called the partial, because these are all partial differentiation involved here. So we can say that this is a partial differential equation of, and it is very famous differential equation, partial differential equation. This is called Laplace equation. This is called Laplace equation. Now we'll go to the further most vital important topic is that order. We must have to know two basic fundamentals of the differential equation. These are order of the differential equation and degree of the differential equation. What do we mean by the order of the differential equation? The order of the highest order derivatives involved in the differential equation. That means the highest order derivatives, which highest order derivative involved in this differential equation is called the order of the differential equation. Now if we illustrate some examples, then it would be more easier to you to know the very familiar concept of the order of the differential equation. First one, that means here it is equation number 7, d24 dx4 plus 4 dy dx whole square equals to 0. So here how many derivatives involved here? Two derivatives involved here. First one is d24 dx4, that means the order of the derivatives is 4, and this is the highest order, so the order of the differential equation of 7 is 4. And the equation number 8. If we see equation number 8, then equation number 8 will give us d2y dx square plus 5 dy dx to the power 3 by 2 plus 3y equals to 0. Here we see that the highest order derivatives involved here. The highest order derivatives involved here is d2y dx square. So it is the second order differential equation. In equation number 9, d3y dx, sorry, there is a printing mistake, d3y dx3, it should be dx3, and the highest order derivative involved here is d3y dx3, that means third order differential equation. This is the third order differential equation, and we at the end of this we have given examples of nth order linear differential equation where a0x d2n dxn plus a1x an minus 1x anx, these are all function of x only. So this is the examples of nth order ordinary differential equation. So time will come to close. So now the rest of this part will be given in my next lecture. Okay.